In this video we're going to talk about compound events, so more than one event happening. In this problem that we're going to look at first, we're flipping a coin and rolling a die. And I want to know what is the probability that I get a head when I flip the coin and a 5 when I roll the die. And we've looked at sample spaces. Here is a grid representing possibilities for the coin, possibility for the die, so we could get a head and a 1, tail and a 1, head and a 2, tail and a 2, so on and so on. And if I continue to put down all the possible events, there's only one event that satisfies what I'm looking for, a head and a 5. That's that dot that is circled with green. So let's look at where this comes from. So I guess the probability here, before we go any further, is 1 out of 12. There are 12 possible outcomes. One of them matches this. Let me ask you this. What's the probability of getting a head? Well, you'd say that's 1/2. Easy. Give me something hard. Okay. What's the probability of getting a 5? And again, you'd probably say easy. It's 5/6. Give me something hard. Not 5/6, 1/6. And so I said, okay, well, how do these two things right here, probability of a head, probability of 5, how are those two probabilities related to this first question I asked? And the way that they're related is we can take 1/2 times 1/6 and get the 1/12 that we figured out with the sample space is the probability of getting a head and a 5. And you might be wondering, gosh, I wonder if that's a coincidence or not. And it's not a coincidence, guys. Conclusion for us. If two events are independent, meaning one has no bearing on the other. So in this example, flipping a coin doesn't affect the probability of me getting a 5 on this dice. The two events are completely unrelated to each other. So if they're independent, the probability of getting A on the first event and B on the second, and we take the probability of A times the probability of B. So a coin is tossed and a die is rolled. Once again, find the probability that we get a tail and a 2. Write down this probability statement that you're looking for. Okay, based on this rule, we should be able to take the probability of getting a tail times the probability of rolling a 2. Probability of flipping a tail is 1/2. Probability of rolling a 2 on a standard 6-sided die is 1/6. So this probability is also 1/12. Nifty, huh? So let's make it more difficult. Sunil, I think I'm saying that right, probably butchering it, but Sunil has a probability of 4/5 of hitting a target. So they're archers, shooting arrows at this target. 4/5 probability of hitting the target. Monica has a probability of 5/6. If they both fire simultaneously at the target, determine the probability that they both hit it or they both miss it. Now I'm going to use a tree diagram for this. So this tree diagram, it's going to have two events. The first event is that Sunil hits it or misses. So Sunil hit, Sunil miss. And then the second event that could happen, or that will be happening, is Monica fires the arrow and Monica either hits or misses. So Monica hit, Monica miss. And I'm getting a little bit into the next video here, but I think a tree diagram illustrates this very, very well. But they both hit it. So that would be a Sunil hit and a Monica hit. Is there any other ways for both of them to hit it? No. Okay, so they both hit. Probability Sunil hit and Monica hit. That's just going to be probability that Sunil hits times probability that Monica hits. So 4/5 times 5/6. 20 out of 30, which reduces nicely to 2/3. And the answer to your question is yes, you do have to reduce this. So now visualize using the tree diagram. Where am I going to be looking at to show that they both miss? Well, the way that they would both miss would be down along the bottom branch of this tree diagram. Sunil miss, Monica miss, they're both having a rough day. So probability that Sunil misses and Monica misses will be equal to the probability that Sunil misses times the probability that Monica misses. Oh boy, it doesn't tell me what the probability that Sunil misses is. Well, it's easy enough to figure out. If it's 4/5 of hitting, it would be 1/5 that Sunil misses. Probability that Monica misses would be 1/6. So the probability that they both miss is 1/30. 1 out of 30 times we should expect both of them to miss the target. So just to sum this up again, let me go back to this all-important rule right here. Independent events, two people shooting arrows, one doesn't affect the other. Probability of A and B is the probability of A times the probability of B.